Let's talk about the syllabus and the courses a chemist and a chemical engineer will probably take through their bachelor. And actually, I've done a series. I did a small informal investigation on different, let's say, universities for the Bachelor of Chemical Engineering. So you want to check that more specifically, you can check out this video playlist right here. In this case, I will show you just very like basic stuff we cover in the courses. So the chemical engineering is more into process engineering, which means how to create processes to manufacture chemical products. And the chemistry syllabus is more about chemistry as a science and its applications. Well, the topics you will typically cover in chemical engineering are general engineering, the theoretical basis of engineering, and especially chemical engineering, unit operations and applied unit operations, and eventually you want to build or design your chemical plant and operate it. So first you understand the basics of matter, inlet, outlet, and so on. Then you start understanding the units, operations, and then you build your chemical plant. Now, in general engineering, you will probably see lots of math, algebra, calculus, differential equations, all that related to math. Then come sciences, plenty of physics, biology, environmental sciences. Chemistry, you will have also a lot, depending on the type of bachelor you have, but typically you have general chemistry, analytical chemistry, organic and physical chemistry. Now, computer solving, you will check out some MATLAB, how to use Excel for solving numerical methods. And I also like that as every engineer, you will have your introduction to engineering, maybe basics on manufacturing, business, marketing, and accounting. Now, the second block will be theoretical basis. We talk about mass balances, processes, energy balances, thermodynamics, physical chemistry, which is also called equilibrium thermodynamics or thermodynamics number 2 or even 3. Transport phenomena is about temperature, velocity, and concentration in the x-axis or in location-based map. Now, unit operations, as the name implies, are equipments or that carry on one single operation. So we got momentum operations, or maybe you call it fluid mechanics, heat transfer, mass transfer, and separation processes, reactor engineering, and once you get those, you're going to probably study unit operations right here. Now for the design and operation block, which is the last one, you will see process control and automation, because these guys right here, these columns, well, you want them to be in steady state, and the best way to do that is via computer and automation of processes. Instead of having one guy going up here to close the valve, you have a system that closes automatically. Computer-aided chemical engineering, and I mean there's plenty of software that help the chemical engineer, most likely the simulation software. Plant design and operation is one of the most important ones, and probably you're going to have one final project involving the building or design of a chemical plant, and you need to include the plant economics, which means how much money, how much investment, how much is going to cost to operate, and when is the return on investment. Now that was chemical engineering. For chemistry, we got these 4 blocks: general science, theoretical chemistry, plenty of labs, and new technologies, which I like to call nanotechnology, biotechnology, or genetics, whatever you want to call it. So I will say something more like applicable, or that it has an actual application in real life. So general science is very similar: math, sciences, and computer solving. I would say it's pretty similar to that of chemistry. Now it's to that of chemical engineering. Now for theoretical chemistry, which will be probably your second year, you have general chemistry, analytical chemistry, organic, plenty of chemistry, biochemistry, molecular thermochemistry, molecular kinetics, dynamics, and once you got all that, you are going to probably check out some of the experiments Because one thing is the theory right here, guys, as the name implies, theoretical concepts, but eventually you want to do some practical work. So you're going to have instrumental analytical chemistry, your organic chemistry lab, product synthesis, general chemistry lab, analytical chemistry. All very probably, or most likely, you're going to have one lab at least per each of these classes. And finally, you're going to see new technologies or trending stuff, or probably very applicable concepts in real life, such as material sciences, molecular biology, which is getting very trendy right now, nanomedicine, pharmaceutical, nanotechnology, all these new, let's say, chemistry, which is not that typical or classical. You will see it probably in the last year, and you will do maybe a synthesis project, or I don't know. There are plenty of opportunities in the chemistry syllabus. And that's what I wanted to show you in this series of syllabus. Now, I will say it's pretty easy to check out the difference. You're going to see theoretical basis. We do some more about the process of the mass balance, the energy balance process, how thermodynamics works, transport phenomena. It sounds very different. Eventually, you're going to see how heat transfer and mass transfers and reactor engineering. What do I mean with reactor engineering is that we are going to study how to build reactors, and we want to eventually build up a plant and understand its economic. Now, compared with chemistry, you will see that, well, you have a lot of theoretical chemistry, sciences, anything ending with chemistry, thermochemistry, biochemistry, kinetic chemistry, well, and you will have plenty of labs. So the good thing is that you will get used to work in the lab versus the engineer that is not that common that he's at lab, so you're going to have plenty of more time at lab. And finally, you will probably do some project or final thesis on your, let's say, interest or your topic of interest.